Let's start off with the molecules of compounds. When atoms of different elements are joined together by covalent bonding, a covalent compound or a molecular compound is formed. Example, formation of water. I have written the formula H2O. It is made up of two elements, hydrogen and oxygen. Remember, compound is always of different atoms of different elements. Now, here I have drawn two hydrogen atoms and one oxygen atom showing their outermost electrons. Oxygen atom has 6 electrons, so it needs 2 electrons to have its octet complete. Hydrogen atom, each one has 1 electron, so needs 1 electron to complete its duplet. Now on the right side I have drawn the structure diagram of water molecule, where you can see that oxygen atom is sharing 2 electrons with 2 hydrogen atoms, forming 2 covalent bonds, 2 OH bonds. This was the example of water. Now we come to the another example, that is formation of methane. As you can see in the formula, it says CH4, which means 1 carbon atom and 4 hydrogen atoms. Carbon atom has 4 electrons, so needs 4 more electrons to complete its octet. Hydrogen has 1 electron, so it needs 1 electron each to complete its duplet. Now, on the right side, I have drawn the structure formula of methane. Carbon atom shares 4 electrons, 1 each with 4 hydrogen atoms to form 4 CH single bonds. So, this was the formation of methane. Now, we come to the formation of carbon dioxide. Now, this is another example for the double bonds. You can see one carbon and 2 oxygens I have drawn. Carbon has 4 electrons in its outer shell, so needs 4 more to complete its octet. Oxygen has 6 electrons, so need 2 electrons to complete its octet. So we draw carbon inside, in the middle, and on the right and left side we draw oxygen atoms sharing the common area, and in the common area you can see there are 4 electrons on both sides. That is, carbon is sharing 2 electrons with one oxygen and 2 electrons with another oxygen. So there are, in a bond sharing part, we have 4 electrons each. Therefore we write carbon double bond O and carbon double bond O, forming 2 carbon double bond atoms. Now we come to the formation of ammonia molecule. Ammonia, nitrogen and 3 hydrogens. Nitrogen has 5 electrons in its outermost shell, so it needs 3 electrons to complete its octet. Hydrogen atom has 1 electron, so it needs 1 electron more to complete its duplet. Now we draw nitrogen in the center, and on the 3 sides we have hydrogens. Nitrogen is sharing 1 electron each with hydrogen, thus completing its octet and forming 3 NH single bonds. Now there is one thing to be mentioned. You can see that since we are drawing these molecules, there are certain electrons which are shared and certain electrons which are not shared. So the electrons in nitrogen, you can see there is a pair on the top which is not shared with anyone. So this unshared pair of electron is called a lone pair, which I will discuss later on. Now we have different ways of representing a molecule. Dot and cross diagram in the first column. You can draw either way, then structure formulas, and then molecular formulas. You must remember that when structure formula is asked, what you are going to draw, when dot and cross diagram is asked, what are you going to draw, and in molecular formula, what are you going to draw. Now we come to properties of ionic compounds. Most ionic compounds have high melting and high boiling points. Now, there must be a reason for this. So, the reason is that ions are held by strong electrostatic forces of attraction, so large amount of heat energy is needed to overcome these forces, which increase the melting point and the boiling point. Due to high melting point and boiling point, most ionic compounds are solid at room temperature and pressure. Ionic compounds are non-volatile, means they do not evaporate. Ionic compounds are usually soluble in water and insoluble in organic solvents. Organic solvents are oil, petrol, and etc. Now, ionic organic solvents are non-polar, that is, there are no charges in it. Whereas ionic compounds, they have ions, charged particles. So, charged particles like dissolves like, that is, the polar is going to dissolve in polar and non-polar is going to dissolve in non-polar. Now we have a question: how ionic compound dissolves in water? Water molecules are polar, that is, they have partial positive and partial negative charges, so are attracted to ions, which weakens the electrostatic forces between ions. As a result, they are pulled apart from their lattice structure and get dissolved. I have drawn a diagram of dissolution of sodium chloride in water. You can see that in the left hand side I have drawn sodium chloride molecules, ions held together tightly with each other, and when we are dissolving sodium chloride in water, we can see that sodium ion is surrounded by water molecule with oxygen pointing towards sodium, and chlorine atom ion is surrounded by water molecules, whereas hydrogen atoms are pointing towards chlorine, or they are surrounded by hydrogen atoms. Now, one thing here is to be mentioned, that is, oxygen, as I have said, partial charges. Oxygen has partial negative charge, so it will attract sodium ion, and hydrogen has partial positive charge, so it will attract chloride ions. In organic solvents, ions remain attached with each other as there are no charged particles to attract ions. Now, there's another property of ionic compounds, that is, ionic compounds conduct electricity in molten or in aqueous solution in water. I hope you understand the meaning of molten, that is, when it is melted. In molten or aqueous solution, ions are free to move, so can conduct electricity, whereas in solid state, as ions are not free to move, therefore they do not conduct electricity. Now, this question is very often asked, and the children, they make a mistake, that is, they, instead of saying ions, they say electrons, which is a very common mistake. So you should remember over here that in the solid state, ions are not free, and in the molten and aqueous state, these are the ions which conduct electricity. Now I have drawn three diagrams, 1, 2, and 3. In one I have sodium chloride, second I have one we have molten sodium chloride, second we have aqueous sodium chloride, and third we have solid sodium chloride. You can see there are two electrodes attached to a battery, and in between the circuit we have a bulb. So when the circuit is complete, if the solution is conducting electricity, this means it is going to pass through the bulb. And in molten sodium chloride, bulb is lightning. In aqueous sodium chloride, it is again glowing, whereas in solid sodium chloride, it is not glowing. This means that in solid sodium chloride, electricity is not conducted. Now, we come to the lattice structures, giant lattice structures of the ionic compounds. We have, I'll mention over here that we have studied the formation of ionic compounds. We have studied the properties of ionic compounds. Now we are going to study the structure of the ionic compounds. Ionic compounds form giant lattice structures. Now, what is lattice? It is three-dimensional regular arrangement of constituent particles called lattice. Constituent particles, now in this case, are going to be ions. Ionic compounds form giant lattice structures. Common example of sodium chloride is given over here now. The sodium positive and chloride negative ions are arranged in a giant lattice. It is a three-dimensional network of ions held together by ion bonds due to strong electrostatic attractions between the oppositely charged ions. The ions are packed in regular repeating pattern. In this lattice, each sodium ion is surrounded by 6 chloride ions and vice versa, having a net ratio of 1 is to 1. So the formula is sodium chloride, that is 1 atom of sodium and 1 atom of chlorine. Now in the diagram, you can see that I have shown over here the three-dimensional structure. Right in the center with a dot, we have sodium ion, and with the cross we have chloride ions. So you can see that on the all sides of sodium we have 6 chloride ions. Now we come to structures and properties of covalent compounds. Covalent compounds may exist as simple molecular or giant molecular structures. Their physical properties depend upon their structures. Simple molecular structures and properties. Substances like bromine, iodine, sulphur have independent molecular unit held by weak attractive forces called van der Waals forces, making weak molecular lattice. Due to the weak forces of attraction, they have low melting points and boiling points. Melting point and boiling point depend upon intermolecular forces, not the actual bond formed. Due to their low melting and boiling point, they exist as liquids or gases at room temperature. Number 2 property, it is insoluble in water and soluble in organic solvents. For example, oil dissolves in dichloromethane. They do not conduct electricity because of the absence of the charged particles, that is, ions. Now I have drawn some structures of the covalent molecules and their lattices. Bromine, Br2, you can see diatomic atoms, molecules, and they are just arranged in irregular pattern in some distance from each other. They have weak intermolecular attractions. Now we have iodine. I have drawn the structure of iodine, diatomic, and in between I have shown weak intermolecular forces. Then we have sulfur. It exists as S8 molecule in a crown-like structure. You can see that in one molecule we have 8 sulfur atoms, and both these molecules are attracted by weak intermolecular forces between them. Now students, after this I am going to give another lecture that is on giant covalent structures and their molecular compounds. These are diamond, graphite, and silica. And also, we are going to study the metallic bonds in our next